Hello, geometry classes. This is Mr. Ensler. I hope you're doing well, that your day's going well, that you have a good weekend coming up. Today we're going over lesson 11.5, areas of circles and sectors. Part of this will be review, part of it will be brand new. Make sure you have a calculator out and ready, and make sure you have the 11.5 guided note sheet. If you don't, raise your hand, and the teacher will give you one. All right, so the first thing to start with is that the area of a circle is pi r squared. You already know that. You've been using that for years. The new thing for today is a sector of a circle. A sector of a circle, as it says, is a region bounded by two radiuses of the circle and their intercepted arc. Bounded, meaning those are the boundary lines of the sector. The two radiuses, or radii, and the intercepted arc. So we really are talking about that piece of the pie. What is the area of that? Okay, and that's what we'll get to eventually, but we're going to review area of a circle. So if you look at example 1 here, find the indicated measure. And so here this circle has a radius of 4.2. We can easily set that up following our area formula. So pi r squared, or in this case, pi times 4.2 squared. Now usually what we would do with this is just type this into the calculator and round our answer. I'll go ahead and round to 1 decimal place. So you type this in also though, and use the pi button on your calculator. Pi times 4.2 squared, and you should get 55.4. And since this is an area, that's going to be 55.4 meters squared. All right, that's one way to write the answer. However, sometimes, especially in future classes that you might take, we'll talk about the difference between an exact area and an approximate area. This is an approximate area. Notice I have the approximately equal to signs, and I had to round. An exact area would be where we leave it in terms of pi. We actually leave pi in our answer. So for the exact area, we would do 4.2 squared, which is 17.64. I'm not rounding, that's exactly what it came out to. And that is timesing pi. And we would just leave it like that. We would say the area is 17.64 pi, and we wouldn't round it. This is an exact answer. This is not a rounded answer. It's kind of just telling you the idea of the answer without spelling out for you what it is. All right. B, we need to figure out the diameter. This time we know what the area is. It's 201 square inches. So we'll start with that, and that will equal pi r squared. All right, let's go ahead and get the r by itself. We're going to have to find the radius first and then find the diameter. And we'll actually divide both sides by pi. So you can tell we're really going to be rounding here. These will definitely be approximate answers. So r squared equals, all right, got to type in 201 divided by pi, and I get 63.98, or if I round to 1 decimal place, that's 64.0, but make sure you are leaving that number on your calculator. We're going to take the square root of it, or we can just raise it to the 0.5 power. You raise it to the 0.5 power, you get 7.99, which, if you round, that's really 8.0. And so that is what the radius is. And to find the diameter, we just need to take that times 2. So the diameter here is going to be 16. Although I'm going to say approximately equal 16.0, just to show that it didn't actually come out exactly evenly to 16, just pretty close. And this is not a area, this is a distance, so it's just going to be inches. Okay, so on to the main thing that we're talking about today, which is finding the area of a sector. And this is kind of like the last lesson that we did back on Tuesday, where we found the length of an arc. And what we did is we compared the length of the arc to the whole length of the circle, meaning the circumference, and then the degrees of the arc to the whole degrees of the circle, which is 360. We're going to kind of follow that same pattern here. And so what you do is the area of the sector, you're going to divide that by the area of the whole circle, pi r squared. So maybe make a little note here that this, in the denominator, is really just area of the circle. So we're doing area of the sector divided by area of the whole circle. On the other side of the proportion, we'll have the arc measure of that sector divided by the arc of the whole circle, which is 360. All right, so let's set this up. We do not know the area of sector QRS, so we can call that x. And we're going to put that over the area of the whole circle. I don't quite know what that is yet, but I can at least set it up. Pi times 5 squared. All right, and then we're going to set that equal to 63 degrees over 360 degrees. Hopefully this seems a little familiar, even though it's brand new, because it kind of follows the same format that we had. Let me just rewrite that there. You can see I'm writing with the mouse. It's not the easiest. Okay, from there we can just cross multiply, so 360 times x equals, and we'll go ahead and type that all in, pi times 5 squared times 63. And I got 4,948 approximately. And then we need to divide by 360. So I'll just press divided by 360. And so now I'll round at the very end, 13.7. Just round to one decimal place. 13.7, and there are no units here, so we'll just say units squared. This is an area. Find the area of the sector. All right, let's do another one. So on the back now, example 3. Find the area of sector QRS. This one has a pretty similar setup. So on one side, you're going to have the degrees, 106, over the total degrees of the circle, 360. On the other side, you're going to have the area of the sector, which we don't know, over the area of the whole circle, which we don't exactly know yet, but we can at least write it out. Pi r squared, so pi times 9 squared. Or if you wanted, just for short, you could write 81 pi. That's the same thing. Okay, well, that was the new part. Now it's just cross-multiplying. So 360x equals, and then we're going to multiply all this on the other side. So pi times 9 squared times 106. Go ahead and enter that into your calculator. Again, use the pi button. Pi times 9 squared times 106. And get kind of a big number here. 26,973 0.7. I'm just kind of writing it down as a reference, but then immediately I'm going to divide that by 360. So make sure you leave that number on your calculator, the full number with all the numbers behind it, and then just press divided by 360. And so you get 74.9. And we do have a unit now. This is feet squared. 74.9 square feet. Okay, so those last two we could just kind of plug into the formula, do our cross multiplying, and get our answer. Let's do a couple where you got to think and do a little bit more than that. All right, example 4. Find the area of the circle Q if the area of the sector is 48 square feet. So this time, we're kind of getting the answer, or at least the answer that we've had before. So we're still going to use the formula. Maybe start with 120 over 360. Now you might notice 120 over 360, this sector is 1/3 of the circle. It's 1/3 of the full circle. So the area of that sector, 48, is going to be 1/3 of the entire area. You might think about a different way of doing this than setting a proportion, but this is kind of the straightforward way of doing it. So we'll go ahead and cross multiply 120x equals 48 times 360. I'll go ahead and just type that in. That's 17,280. And then divide by 120. And you should get 144. And this is in feet, and this is an area. We're finding the area of the whole circle, 144 square feet. The other way that I was talking about figuring this out is if you realize that this sector is 1/3 of the whole circle and it's 48 square feet, you could just times that 48 by 3 to come up with 144. And you still have to show some work and explain how you got that, but you can do it that other way. All right, on to example number 5. Okay, find the area of the shaded area, or the shaded region, I should say. Well, we have a circle with a triangle inside, and it's an isosceles triangle. I can see that because this is a right angle. I know both of these radiuses are the same. This is a radius because it goes from the center of the circle to the outside. This is also a radius. And so we've had this situation before in chapter 10 where if this is 5, like they're pointing out that it is, this is also 5. And so it's like one big triangle or two small congruent triangles. And we have to figure out what the radius is so that we can figure out the area of the whole circle. So what we're going to do is we're going to do the area of the whole circle, and then we're going to subtract out the area of the triangle or triangles. So the area of the whole circle minus the triangle. All right. Well, really, this part of the triangle, the height line of the triangle, is also a radius. So, if we just took one of these small triangles out, I'll just take this one here, kind of in the lower part. It has side lengths of r and r because they're both radiuses, and the hypotenuse is 5. So, if I wanted to figure out what these are, I could use the Pythagorean Theorem. R squared plus r squared equals 5 squared. So adding r squared and r squared, I have 2r squared equals 25. I would then divide both of these by 2, so that way r squared is just by itself. 25 divided by 2 is 12.5. And then take the square root of both sides. You can see this is not going to work out evenly. And the square root of 12.5, if I enter that in, I get approximately 3.5. But where I'm going to use that number right away is to do the area of the whole circle, pi r squared. So hopefully you have not pressed clear on your calculator yet. Don't press clear yet. And we're going to do pi r squared. So do that 3.5 number and just square it. Oh, wait, it's going to go right back to 12. So this is really going to be pi times 12. And maybe I'll just leave it like that for a second. We want to do minus the area of this triangle. Well, the area of this triangle is 1/2 base times height. The base of the triangle is this diameter line, and so that's 3.5 and 3.5. It's approximately 7. The height of that is 3.5. So I would just enter all of this into your calculator at once. Pi times 12.5, that should be 12.5 there, minus 0.5 times 7 times 3.5. And it comes out to 27.01, so approximately 27.0, and we are talking inches, and since this is an area, inches squared. So kind of a not so straightforward problem, one where we had to think a little bit more. And actually this problem did not even involve area of a sector. It really just involved area of a circle. Okay. Let's go on to the last problem. It says the area of circle M, so the whole circle, is 260.67 square inches. The area of sector KML is 42 square inches. All right, they're giving us both areas. Find the perimeter of sector KML. All right, now the perimeter consists of, I guess, 3 sides, but really 2 of those sides are the same, because these 2 sides are both the radius. This side right here is an arc length. So we're going to have to remember a little bit of what we studied earlier this week on Tuesday in lesson 11.4. Okay, so let's see if we can find R. If I know the area of the circle, 260.67, I should be able to set that up according to the area formula. Area equals pi r squared. Okay, and so I'll divide both sides by pi. That way we'll get r by itself. And, well, at least we'll have r squared by itself. So 260.67 divided by pi, I get approximately 82.97. I know I usually just round to 1 decimal place, but I'm not finished with the problem yet. And then I need to take the square root of both sides. You can either press square root and then do ANS, if you remember how to do that, or remember that other shortcut way to take the square root of a number is to raise it to the 0.5 power. So you'd press caret 0.5, and it's approximately 9.1. Okay, so I know two of the sides are 9.1. What I need to figure out is what angle is this at? What percentage of the circle does this take up to get that other side? So what I'm going to do is use the sector formula that we just learned today, because I don't know what this angle is, and that's what I want to figure out. So I'll call that angle x, and that's going to go over 360. On the other side, I know both of these areas, 42 and 260.67, and so I should be able to cross multiply to figure those out. So 260.67 times x equals 42 times 360 is 15,120. And then I'll divide that by 260.67. And I get approximately 58. Now, that's 58 degrees. That's not my answer for the arc length, but now I know that this is 58 degrees. So now I can use the formula for arc length that we learned on Tuesday. And so what I do there is I put 58 over 360. And on the other side, it's the arc length that we don't know. I'm going to call that arc KL. I'll put the little arc symbol over it. And that over the circumference of the circle. Circumference, if you remember, is pi r, or not pi r squared, excuse me, 2 pi r. So 2 pi times 9.1. All right, 2 pi times 9.1. So I'm going to have 360 times arc length KL equals, all right, I'm going to times 2 times pi times 9.1 times 58, because I'm cross multiplying. And I get like 3316 maybe 0.26 or 0.3 to round. I'm not done yet, so. And then we have to divide that by 360. We will know the missing piece to our pi, at least approximately. So divided by 360, and you get 9.2. Okay, so we have side lengths of this sector of 9.1, 9.1, and 9.2. And so if we add those up, 9.1 plus 9.1 plus 9.2, we will have our perimeter of the sector. This is probably about the hardest problem that you would deal with sectors, so hopefully this made sense. And you should get approximately, this is very approximate, we've been rounding all throughout this problem, 27.4, and we have a label, inches. And that's not an area, that's a perimeter. That's a distance around. All right. Let's go ahead and start the homework together. So if you want to take out your homework packet, 11.5, Let's take a look at the first two problems. It says find the exact area of a circle with the given information. Okay, so remember what exact means. It means we're actually not going to round. I think the rest of the problems in this homework you're going to round, but these ones it says exact. So the area of the circle is pi r squared, or in 1a's case, pi times 5 squared. All right, we know 5 squared is 25. And so instead of typing that into the calculator, pi times 25, and rounding it, we're just going to leave our answer as 25 pi. There will be some times where this is very useful to leave it as an exact answer, and there'll be some times where it's not useful, where it's more useful to multiply it out, 25 times 3.14, and get an answer that we round. All right, over here, the diameter is 23. Well, pi r squared is our formula, so we don't want diameter, we want radius. So you're going to have to take 23 divided by 2, and you get 11.5. So back here on part A, I should still label that inches squared. 25 pi inches squared. Okay. Back here to part B. The radius is 11.5, so pi times 11.5 squared. Okay, go ahead and type that part into the calculator. 11.5 squared is 132.25, and I'm not rounding. That's exactly what 11.5 squared equals. So our unrounded area is 132.25 pi square centimeters. All right, you have the rest of the class to do the rest of this. And the last problem, we did not go over the last problem on the homework, so that's something that we're going to go over on Monday. So if you want to skip the last problem on the homework, let me see if I can find that here. Nope, I guess I don't have it. You can skip the last problem on the homework assignment. We'll go over that on Monday.